Hi everybody, this is Miss Faina. Today we're going to be talking about transformations in function notation. So function notations when we have f of x, g of x. Okay, we're going to start with the quadratic parent function. So the quadratic parent function is x squared. Okay, we are going to be graphing that in our calculator as well as the transformations. So here we go. We're going to start with a vertical shift up and down. So notice that when I have a shift that is up or down, I have a plus or a minus on the outside of the parentheses. So it is not within the parentheses with the x. So what we're going to do on the example is we're going to graph our parent function in F1. And we're going to graph our transformation in F2, and we're going to end up writing it out almost exactly like it looks. So when I go to my calculator, I'm going to go to a new graph. I'm going to type in the parent function into F1 of x, so x squared. Then I'm going to use the down arrow to go to F2 of x. So what I'm going to do is I'm going to write F, the parentheses, and then inside the parentheses x, close the parentheses. Okay, and then I'm going to say that it goes up 3 because that was the plus 3 on the outside. So plus 3 looks just like that. And notice when I graph it, it didn't graph for me. Oh, I forgot to put the 1 with it. So it's F1 of x. You got to make sure you put the 1 with it. There we go. Now when I hit enter, it's going to graph it for me. Okay, so notice how it has F1 of x equals x squared, and then F2 of x equals whatever F1 of x was plus 3. So it moved it up 3. So on our notes, what we're going to do is we're going to sketch a little rough graph that says that it goes up 3. So it started here at 0, 0. So 1, 2, 3, and it just goes up just like that. Okay, so when there is a plus on the outside, it's going to do a vertical shift up. So this one did a vertical shift up 3. Okay, now, whenever there's a minus sign, if a plus sign made it go up, the minus sign is going to take this graph down. So what we're going to do again is we're going to change that f of 2 to be this equation right here. Remember, the only thing that's going to be different is we're going to have a 1 after the f. Okay, so in my calculator, I'm just going to hit tab or this circle with a plus sign, go up 1. Okay, I'm going to leave that F1 of x because that's our parent function, but now I'm going to put minus 2. And notice how it shifted it down 2 units. So it shifted vertically down. So vertical shift down 2. So again, just a rough sketch, nothing too pretty. Okay. Now, we have a horizontal shift. So vertical goes up and down, up and down. Horizontal is going to go left or right. Okay, so we're going to talk about shifting it right. So notice now it is inside the parentheses. When it is inside the parentheses, it's going to move it to the right. Okay, we kind of think opposite. It looks like it's a minus sign, but it's really going in the positive direction. So we're going to take this blue graph and we're going to move it to the right. So I'm going to graph it. Okay, so I'm going to hit tab. I'm going to go up and I'm going to edit that. So remember, when we do this, we type in F1 and then we do our parentheses, and inside the parentheses we put x. And also we're now going to put x minus 3 and then close the parentheses. So F1 tells me that I'm using the parent function that I graphed above, and then inside the parentheses x minus 3, which is what we had on our notes. I hit enter, and notice how it goes to the left 3 units. So it moved it over 1, 2, 3, just like that. So it was a horizontal shift right 3. And you will always get the numbers from the equation. Okay, we're not going to use any numbers that aren't in the equation. Looking at the next one, horizontal shift left. So again, it's going to go to the left. Again, it looks like it would be positive, but remember, we always think opposite. Okay? Just like you act opposite in your house than you do at school, so do the movements with the x. Okay? So we already have our parent function graphed in, but we're going to change it to x plus 2 inside the parentheses. Okay? So I'm going to hit tab or the circle with a plus. I'm going to go up. I'm going to edit inside my parentheses, and it's going to say x plus 2. Close my parentheses. I hit enter. So notice how the red graph now moved to the left 2 units. So this was a horizontal shift to the left 2. So 1, 2, it moved over 2 units just like that. And we're just doing a rough sketch. Nothing needs to be perfect as far as the graphing. Okay. Next, a reflection across the y or the x-axis. I'm sorry. So notice how now it has a negative out in the very front of the f. So what we're going to do is it's basically going to flip it upside down along the x-axis. Okay, it's going to be a mirror image just going the other way. So what we're going to do is we're going to graph this right here, and we're just going to make sure that we put a negative out in front of the f of x. So again, I'm going to hit tab or the circle with a plus sign. I'm going to go up, and I'm going to edit this equation. Just as a reminder, my f1 has the parent function. f2 is the one with the transformations. So I start with a negative f, and then I have to put a 1 with it, and then parentheses with the x, close parentheses. Okay, that tells me I'm using the parent function with a negative out in front. So notice how it just flips it upside down. It's a mirror image on top of each other. So this just goes, oops, down from here. Okay, just opens it down. So this is a reflection across the x-axis. Okay, looking at the next one, we have a vertical stretch, okay, versus a vertical compression. So these are both with A, but the difference is one is going to be when A is bigger than 1, and the other one's going to be when A is between 0 and 1. Now remember, this does not say negative. If it's negative, that's when it's going to be a reflection. So it could have a negative and a number. That means it's 2 different transformations. This one is just talking about the A. So I guess we need to say the absolute value of A. Okay, the absolute value of A. So let's be more mathematically correct. So let's show you what a stretch looks like. If you have like a hair tie or rubber band and you stretch it, you think about it getting skinnier. So that's what it's going to do here. So I'm going to hit tab or the circle with a plus sign. I'm going to go up, and I'm going to erase everything, and I'm going to type in 3f1 of x. Press enter. So look how the red graph got skinnier. Okay, it's like we're stretching it tall. Okay, that's why they call tall people stretch. Okay, so this was a vertical stretch. Of 3. Again, we use the numbers from the equation. So again, it makes it look like it got skinny. Okay, we stretched it tall. Okay, let's look at the vertical compression. So now I'm going to type in 1/4 in front of the f1 of x. So I'm going to hit tab or the circle with the plus sign, go up. Okay, I'm going to erase everything. I have 1/4 f1 of x. I hit enter. So notice when I compress it, it's like I'm squishing it closer to that x-axis. It got a little fatter. Okay. So this one makes it, oops, a little bit thicker. Okay. And we call this a vertical compression. of 1/4. So these are all those transformations. So really it's just going to be practice using your calculator and understanding how it's moving, whether it goes up, down, left, right, we stretch it or we compress it. But it's always based on the parent function, and the parent function we're using right now is f of x equals x squared. So that's what's always graphed in the first function. And then in F2, you can type it in exactly as it looks on your question. So if you have any questions, please make sure you ask your teacher. We're here to help you. Other than that, have a great day.